I stole this idea. Well, I didn't really steal the idea. I mean, I made connections to it. But the most recent paper I posted to Vixra has to do with an island of stability, per se. Now, the nucleotide island of stability, I believe it's claimed to be this area right up here for heavier and heavier elements. And the red is more stable, and as you go up and as you go down, it becomes less stable. The rate of radioactive decay is increasing for the lighter, or the bluer and bluer colors. I think that's what they claim the island of stability is, but originally I had believed the whole island was the central region. That whole, shall I say, mountain range, if you want to look at it like that. Like, the black is the stable, nucleotides. And then as you move outwards to the blue, imagine that's like the ocean, and this is the topographical map. And the black is like the peaks, and those are where the elements are the most stable, and they're not going to decay. So when you move out from the center up or down, the elements become less and less stable. They fly apart due to radioactivity. So I thought this whole island, this whole strip, I considered to be the island of stability. I don't know, some websites have it as just this area, but I think it's the whole thing. That's the whole island. And we know islands can be long like that. And that being said, I have what I call here the island of stellar stability. Now, I know Baz tried to make a graph. Now, with the reason why it wasn't working so well is because the extremes are so high. The younger planets are so much more massive than the older ones, like the Earth. So what you'll see here, the island of stellar stability, the star as it evolves moves down to the lower left, to the 0, point, right there. Yeah, I have the other, down to the 0, point. Now I just put this on a word diagram here, but basically what you have on the bottom is the Jupiter radii in reference to the stars, and you have the Jupiter mass. So where the sun is on this, it's at 10 Jupiter radii about, and 1,000 Jupiter masses. So the sun sits right about there at 10 and 1,000. And then the younger, hotter suns that are bigger and more massive go up this direction. And then as you move down, these would be red dwarfs, or no, orange dwarfs and red dwarfs all down here, and then brown dwarfs. And basically the majority of the planets are like down in this general area right here. Planets. They're evolved, highly evolved stars that have cooled and lost basically almost all of their mass, relatively speaking, to the hotter, younger ones. But as you'll notice here, there's an island of stability, and this is the island of stellar stability, meaning for stars that are stable, they'll be found where this line is, for the most part. They'll be on this line. If it's an unstable star, then it's not going to be there. It's going to be off willy-nilly, doing its own thing. And another reason why I did this is because if you have something that's stable, then you can make predictions concerning it and where it's headed in its evolutionary path. And a lot of establishment stuff, they don't have any predictions for red dwarfs. They just say they're just gonna burn out or whatever. To them, a red dwarf becoming a brown dwarf has completely escaped them because, well, clearly they haven't, as some of my listeners have told me, connected the dots. And as you'll see there, the dots connect themselves over time. And that's exactly what's happening. You fill in all those dots, the dots touch each other, and it becomes a line. So you don't even have to draw lines in between them. I guess that's just simple geometry. But for this graph, Yeah, for this graph, I added about 230 objects from the Kepler data, and I also put down which Kepler stars were on there on the graph on the Vixra page. I only printed out 2 of these. It's a whole 7 pages long. But yeah, that being said, another thing is that I think it's wise to look at stars as being stable constructs. I think back in the 30s and 40s, and 20s, 30s, 40s, and 50s, and 60s, a lot of the astrophysicists and astronomers, they looked at the stars and they just went willy-nilly with them. Their minds just went into fantasy land and said, well, this is this, and this, and this, and this. And a lot of it was fear-based. A lot of it was based off of confusing math for physics. A lot of it was, fantasy. A lot of it was you have these people that work in these universities that, they can't be questioned because, they have such high status in the academic community. And then they were just making up whatever they wanted to make up. So it's a mix of confusion. It's a mix of misdirection. It's a mix of misinterpretation. And I think as more data comes in and we learn that stars are not these fantastic exotic things, that they're very real, that they're very understandable, and they can be stable like this and predict where they're headed on a little graph here. I think as we move away from that kind of fantasizing and mathematical 20th century stuff into the 21st century, we're going to kind of wake up. And this understanding is going to become, like another listener told me, it's a more spiritual kind of awakening. But not really spiritual in a sense that we can't understand it, but more or less, we're not just star dust without rhyme or reason or purpose on the earth. The earth itself formed life as it was evolving. And we are literally the end result of many billions of years of this thing evolving and cooling. We are breathing, we are made of it, and we're going back into the earth to be recycled back into the atmosphere again. It's really weird. Not only are we related to all life, but we're physically, intimately related to the earth itself. And that, I don't think it gets any more spiritual than that. I mean, think about all those tree huggers out there. That's a pretty wild thought, huh? Alright, there you go.